Yeah. Okay. So, wow.
I think that's a sign.
Yeah, we should quit today and start over tomorrow. Okay. Kaya has completed 25 quizzes in the science class so far this year. Her scores on I can't read what that word is, average of 87.5 with standard deviation of 6.7, or 87.5 and 6.7 statistics, or parameters. Use the correct symbols. So, statistics or parameters. Why is it parameters? It's her population. Okay, what's up? It is the mu symbol. Okay, so mu is going to equal 87.5. And then the standard deviation, which is sigma, is 6.7. Fabulous. Great. Questions?
You don't need to calculate anything else.
No. No.
Okay, sorry.
Describe how Kaya could create the sampling distribution of the sample mean by taking samples of size 2. Okay. So what should she do? She could list out all possible sample size of 2 and calculate mean for each sample, and then do a dot plot. So this is just talking about the process of how to get from the population to figuring out the mean of each sample and then graphing that data. Okay, what's the mean on this one? What's the mean going to be? It's going to be the population mean, okay? So mu, sub x bar, is 87.5. Now standard deviation. With standard deviation, what is our formula for that guy? Okay, so you're doing standard deviation divided by the square root of n. And what is that going to give us?
The sample, the number, like how many?
Okay.
So it should be.
So what should we put?
Divided by the square root of 2, which is 4.74.
4.74. All right, so Victoria said it again.
Oh, so the equation for standard deviation is going to be the population standard deviation.
No, we're like
over the square root of the sample.
Okay, so 6.7 divided by the square root of what? Okay. And that's going to give us 4.738 or 4.74, whatever you want to put there. All right, what condition must be met to use the formula for standard deviation? 10% condition, yes? Okay, so 10% condition. So is 2 less than or equal to 10% of the population, which was 25? Is that a true statement?
Yeah.
Yeah.
Did you say again?
Yes. Questions, comments, concerns, inquiries.
If it was just like a zero, we saw something about the problem in letter C, would you do 6.7 divided by the square root of 25?
If we took 25 as a sample, yeah.
Oh.
Yeah. Because otherwise we've already found our standard deviation for that sample then. Like, if 25 is our sample, they told us this information about our sample, we wouldn't have to do this calculation. It's already found it. That makes sense?
What's B out?
What is B asking? To describe the process that we do. So like yesterday when we were working out our notes, like this is what we did. We took samples. Each one of you would have done a sample of 2, found the mean, and we would have plotted it. And then we could ask these questions then.
Okay.
That's all it's saying. It's saying, what is the process for it? All right. All right, number 2. AP Stat teachers at a large school. Yeah, exactly. Okay. Conducted a census of all AP Stat students to learn more about their students. What is a census? It's every single person's taking it, right? Okay. One question in the survey is how many different social media accounts do you have? The dot plot and summary statistics of the results are shown. Those are super tiny. Describe the population distribution. What does this look like? Okay, approximately normal. But when you say approximately normal, you have to define the mean and the standard deviation. Okay, so don't just say approximately normal. You got to do mean and standard deviation. So, I'm sorry. Yeah, what's the mean? 3.23. 3.23. And we're pulling that from there. You can't see it. There it is. That one. Okay. And then the standard deviation is what? 1.35. Okay. And we're going to say it is approximately normal. If you were on the AP exam, you would want to talk about it in context. So it's approximately normal with the distribution of whatever we were talking about. How many different social media accounts do the AP Stat students have? Somebody watching a video that's me? Okay. I was like, I swear there's like a kickback in here. Echo, like. All right, part B. One of the AP Stat teachers selects a random sample of 15 responses. The graph and the summary statistics are shown below. Describe the distribution of the sample. What is this? What is this? Skewed right. How do we know? Okay. And then we got to talk about the mean. And we got to talk about the standard deviation. So mean is 2.53. Standard deviation is 1.3. Okay. Again, putting it in terms of, hey, this is how many social media accounts they have with the 15 students that we pulled. We're okay? Okay. All right. Suppose the teacher selects every possible sample of size 15 and record the average number of social media accounts for each sample. What is the name of this type of distribution? Sampling distribution of sample means. Okay, so sampling distribution of sample means. Okay, so look at it this way. The average number of social media accounts. So they're going to take a sample. They're going to ask each person, hey, what's your average? And then they're going to average that together. Okay, that's why it looks really stupid when we write this out. Sampling distribution of sample means. Gucci. Okay. Describe the distribution in part C. What would be the distribution in part C? No. Approximately normal. Why would it be approximately normal? No, you're not. Approximately normal. Why?
Because the original.
Okay. So the mean would be 3.23. And the standard deviation, if you calculated it, would be 1.35 divided by the square root of 15, which would be 0.349.
So
349. So this one right here is describing this one. It's from the original to this one. Yes. We're pulling out a sample of 15 people. So the mean is going to be the same. We're going to be approximately normal because the original is approximately normal. Okay. And then the standard deviation is going to be 0.349. Questions? Do what? Right. Okay.
The original distribution at the meeting sample.
Yep.
And then for number B, we say like. Yeah, like we describe how the shape of like the sample of 15 responses. If those means deviation I'm seeing, we describe what the heck we're doing with sample distribution. And we one more distribution because
You're finding the average number of social media accounts.
And those 15 people you picked plus the average. And then we're gonna do that multiple times.
So instead of using the word mean, I would use sample average. That would make more sense. Family distribution of the sample average.
Yeah.
But that's what the title's called. 0.349. So this is finding the standard deviation of the 15 people that we had. Nope, different one. Yep. So this is one sample. Here's another. Yeah. All right. Girl Scout troops. Oh, plot twist. Taylor lore. Andy quit Taekwondo, the 4-year-old, and now she's gonna be a Girl Scout. That's what I said. I said boo. I said that's so stupid. Do better. I mean, okay, if you want to be a Girl Scout, that's great. But like, do something else too. So now we're gonna sell a bunch of cookies. It's gonna be great. They do. They do. They do. But she's 4. So who's really gonna be doing the community service?
Yeah.
I don't want to do this. I do enough community service. I teach. Yeah. All right. Number 3, let's go. Bring it back. Girl Scout troops in a certain state receive a bonus donation from a large corporation. See, it's all about money. Number of boxes of Girl Scout cookies sold by their members. Determine whether or not the troop receives the bonus donation. One Girl Scout member is selected at random, and the number of boxes of cookies sold for that member is counted. Number of boxes of cookies sold for members of Girl Scout Troop A, God bless, is approximately normally distributed with the mean 25 boxes and a standard deviation of 4.6. If more than 30 boxes of cookies are sold by the Girl Scout randomly selected from Troop A, the entire troop will receive a bonus donation from the corporation. What is the probability that the Girl Scout Troop A will receive a bonus? How do we do this? Z-score. All right, what is that going to look like then? 30 minus 25. 4.6. What does that give me?
That's a great question. 0.0869.
Okay, and then we go to our fancy dancy table. And what do you get?
I don't think that's exact value because it's the calculator. 0.139.
P-value is 0.139. No. If more than 30 boxes, did you put in 1 minus P? You did not?
Wait, no, I did.
Okay, so something to keep in mind. You should do 1 minus whatever the Z-score table number you got. Yes? Does everybody understand how to do that? Because you got to do it on your quiz. Okay. No, this is what your final answer is. This is what your final answer is. You would do 1 minus whatever the Z number is. So 1.08, go into your table, whatever the number is in the middle. 1 minus that number. Reading is fundamental. Yeah. No. All right. Corporation providing. I'm not reading it. Okay. So on this one, would Girl Scout Troop A be more likely, less likely, or equally likely to receive a bonus donation from the suggested plan compared to the plan described in Part A? Talk to me. What you got? Less likely, why?
Score was more the 30 or less. Let's get rid of the 30 or more.
All right, so she said that there's less variability, right? Because we upped our number, right?
Yeah.
Okay. What else? Go ahead, Caitlin. Go ahead.
Okay. So because the standard deviation would be smaller, the Z-score would be greater, which would mean that the area covered for 30 or less is greater and the area covered for 30 or more is less.
Yes, no, maybe. So increase our sample size, less variability. Okay. Which means that they don't have as greater of a chance. Yes. Okay, your Z-score goes up, probability changes. Okay. Your Z-score goes up, you have less probability of getting it. Yes. Good. Lots and lots of reading. Love it. All right. Wow. Okay. All right. Love that I'm recording. All right. For a state exam, fifth grade students receive scores from 1 to 5. The state exam scores of all 100 fifth graders at a small school follow a normal distribution with a mean of 3.2 and a standard deviation of 0.5. School principal plans to select a random sample of students and find the average score of the state exam. If the principal wants to use sigma over square root of n, like Jad would do that. All right, sorry. To calculate the standard deviation of the sampling distribution, what is the size of the largest sample that can be taken? What's the biggest? All right, so how do we go about doing this one? 10% condition. All right, so what is that going to look like? How many people do we have in total? Okay, so out of the 100, what's 10% of 100? Oh, wow. Wow, what's the size of the largest sample that can be taken? It would be 10. Oh, boo. I know. Dude. All right. Caitlin always gives me hope that we've learned something in this class for the rest of y'all. Suppose the principal selects 8 students, find the mean and the standard deviation and the sampling distribution of the sample mean. Okay, so what is the mean going to be? The same. Okay, so 3.2. Good answer, good answer. The same. All right, standard deviation. You're going to take your standard deviation, divide by the square root of the sample. So 0.5 divided by the square root of 8. I don't know what that is. 0.177. Hey, you're welcome. All right. Half the students in the sample 8 were absent on the day of the exam. So the principal can only select 4 students. How does this change the sampling distribution for the sample mean? What is it going to impact? Variability, right? So we decrease the sample size. So we increase the variability. Okay. What else is anything else going to change? Is the shape going to stay the same? Yes, the shape will stay the same. What about the mean? It'll stay the same. So the only thing that changes is your variability, which is standard deviation. Okay, so standard deviation will go up. The shape and the mean is the same. Okay, words? What'd you say about decreasing the sample size? Decrease the sample size, increases the variability. Because, like, if I look at 4 people in this room's grades in this class, it's going to be all over the place. But if I do all of you, it's going to be a little closer together. Okay. Go ahead and skip to 6 and 7. Or skip 5. No, bro, the 11, 12-year-old boys on the swim team literally say that. Why are we? Is it Mo touching you? Is it Mo? Okay, number 6. Distribution of PSAT scores for the students at a large high school with a mean of 1,020 with a standard deviation of 110. Let X bar represent the mean PSAT score for a random sample of 30 students at this high school. Which of the following calculations will be given the approximately probability that X bar is more than 1150? What's your answer? Why? Well, there, yeah. Okay, so what is this actually showing? H, back corner. Okay, so we're taking our number that we want minus the mean there, divided by the standard deviation divided by our sample. Okay, why is Z greater than though? Because it's giving what?
It's like, it's right. Looks right. More than. So if the, if the Z, right?
Z is greater than. Reading is. Yeah. Welcome to AP Stat. All right. Number 7, last one. It was A. Yeah.
When we, it's like asking for
Bruno, we literally said we're skipping number 5
like.
because we're running out of time and you're not gonna be able to take a quiz in time.
Oh
Oh my gosh. All right, on 5, part A, 5 part A is 0.5251. And B. Y'all are wasting time. Like, all right, on 5A, it's 0.5251. On part B, hey, babe, go pick up paper.
I was gonna say.
You're okay. Okay, grab paper. On B, the sampling distribution of the sample mean for the sample of size 5 is approximately normal with a mean of 52.1 and a standard deviation of 4.696. 5C is going to be 0.0049. On 5C, it's 0.0049. Okay, now back to 7. Suppose the sampling distribution of the sample means for samples of size 25 is approximately normal with a mean of 100 and a standard deviation of 10. Which of the following is the closest to the population standard deviation? No. Okay, so what is your standard deviation? 10. And then we're dividing it by what? 25. Square root of 25. That should be 2.
Yeah.
Why does it 50? Yeah, why would that say 50? Which of the following is the closest to the population standard deviation? Oh, because this is giving, reading is hard. Okay, this is giving the standard deviation of the sample. We all got. Okay, so here it is again. 10 is what the result is. Yes. And we're trying to find X. So what's square root of 25? All right, now we're solving for X. 5 times 10 is gorgeous. Reading is hard. Yes, reading is hard. Just Caitlin is the only hope. What, Bruno? Are you gonna ask me about 5 again? No.
We find like Z-squared, like both the Z-squared. What do we do with both Z-squared? We subtract this.
Subtract the 2. You find the population or the probability and then subtract the 2. No. Take Z-score. Find the number. Take Z-score. Go to your table. Find the probability. Do it for the other one. Subtract those 2. That's the answer.
Yeah.
Okay. So, really quick. All right. On your quiz, here are the types of questions you got. Describe the shape. So, like normal, skewed right, skewed left, blah, 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 blah. Okay. Number 2, find the mean and the standard deviation of the sample. Okay. Whether it's like increasing or decreasing based on the population. Okay. That's all I can give you on that one. And then the next one is find the probability. So using the Z-score, going to the Z table. Okay. For greater than, don't forget your 1 minus. Okay.
One minus.
All right, number 4 is finding the standard deviation difference. Remember, for your difference of standard deviations, we're going to square root sigma squared divided by n, okay, plus sigma squared divided by n. Everybody got it? It's just divided by n because you're square rooting the whole thing. Good? Okay. Number 5 is talking about interpreting the probability in terms of what they're talking about. Okay. And then 6 and 7 is describing the shape, finding the mean and the standard deviation, all the things that we just practiced. Okay. There's one of those questions that's like more likely, less likely for something to happen. Very similar to what we just went through. Questions? Yes, Bruno.
I mean, question, how do you got? You did
I mean, they're gonna give you the mean on this. They don't make you find the mean. It would be take all of your sample, divide by how many things you had. What? Sigma squared divided by n plus sigma squared divided by n. Take the whole thing square root. Yeah. If I can see that far. I think that's what it said. Okay,